The common ion effect is a difficult but very important MCAT topic, and we're going to look at everything that you need to know. And if you like these videos, check out the link in my bio for over 500 pages of images and typed out explanations just like these. In a problem where you have calcium fluoride, which has a very low KSP showing that it's not soluble, if we were told that this is a saturated solution, we would want to use an ice table to figure out what the concentration of calcium and fluoride are. The way we would do that is to say that we start with 0 of each, and then we add X for the calcium, and we add 2X for fluoride because we have 2 fluoride per calcium. Then at equilibrium or saturating conditions, we have X and 2X. We write the equation for KSP, which is equal to the concentration of calcium 2 plus times the concentration of fluoride minus raised to the second power, because we raise it to that coefficient of 2. And then you just plug in X for calcium and 2X for fluoride. In this case, however, we're going to show the common ion effect. And what happens there is they also give us a different compound that has one of the ions from calcium fluoride. For this one, let's say we have sodium fluoride. That's going to dissociate into sodium plus and fluoride minus ions. Let's say that we have a 0.1 molar concentration of our sodium fluoride, and sodium is completely soluble no matter what it's paired with, so all of the sodium will dissociate from the fluoride, and that means that the fluoride concentration is going to be equal to 0.1 molar. So instead of an initial concentration of 0 in our ice table, we start with 0.1 for that fluoride concentration. And that also changes what we end up with at equilibrium or saturated conditions. Calcium is still just X, but then the fluoride concentration becomes 0.1 plus 2X. Now we just need to plug in everything into this equation. The KSP is equal to 3.9 times 10 to the negative 11. The calcium concentration is just X, and then the fluoride concentration is 0.1 plus 2X, but we have to square that. So all of that in parentheses gets squared. Now we can cross out the 2X because since calcium fluoride is not very soluble at all, the 2X value is going to be extremely small, and it's going to be actually negligible compared to 0.1. So 0.1 plus 2X is still going to be pretty much just 0.1, and that means we can just cross it out. That leaves us with X times 0.1 squared, and that is equal to X times 0.01. Now we have 3.9 times 10 to the negative 11 is equal to 0.01x. 3.9 times 10 to the 11 divided by 0.01 is the same thing as multiplying it by 100. So x is equal to 3.9 times 10 to the negative 9, because if we multiply this by 100, we change that negative 11 to a negative 9. Then we can take x and plug that back in to the equation and get the concentration of calcium 2+.